all this just put in your brain. Okay? There you go. No big deal, right? Okay, got it? Perf. So here's the deal. If you want to switch the bounds, you got to negate the whole integral. Okay? If you're integrating from like the same value to the same value, that means there's no width, right? If there's no interval to find an area of a rectangle on, there's no width. So that integral is going to be 0 because there's none, you can't find the area. This is the evaluation theorem, essentially the fundamental theorem of calculus. This is a big one. It's basically when you're integrating on a closed interval, okay, you basically take the antiderivative, plug in the upper bound, minus plugging in the lower bound, okay? So that's how you do that. And then mean value theorem is basically, it's kind of like the antiderivative. It's still the mean, it's still the mean value theorem. It's just like the antiderivative of it, kind of. Because think about it, if you took the derivative of this, it would be f prime. So it's like, remember, mean value theorem was like the average rate of change equals the instantaneous rate of change. So this would have been like f prime. And then if I integrated that, actually, I might just write it. Hold on. I'll show you. It's literally the same thing. So here's average value. That's part of the formula. So we'll just write that in here. So let's do one that's like we're used to, like, what do you want to do? Average velocity. How about velocity? You interchange between this formula and the slope formula. So average rate of change and average value, it's the same formula. It's just whatever's easier to find. Okay, so like average velocity, technically what you would get to find it, you would take like, if I follow the formula, it'd be 1 over, and then you would do like the B minus A thing. So that would be, think about what that would be. B over A, what unit is that? Or B minus A, sorry. What unit is B minus A? Seconds or time, or right? So this is going to be like seconds maybe. Okay, and then if I follow the formula, you would integrate then. You would integrate from A to B, right? And then you would integrate for this formula. If I wanted average velocity, I would put velocity in there. Okay, and I'll promise you, I'll show you why it works. So I put velocity in here. Okay. Now, if I did the antiderivative, I obviously don't have the formula, right? So this would be 1 over B minus A. And if I did the antiderivative of velocity, wouldn't that be like position, right? So like antiderivative velocity would be position. So I don't know. Do you want to just do F? I'll call it F. And you would do the antiderivative. So you get F, right? F of t. Here, maybe I'll just show this. From like A to B, right? Do you know what I mean? Do you remember that with the bar? And then you'd like plug in the B and the A. So if you keep going, you get 1 over B minus A. And then this thing turns into F of B minus F of A, which you see it's literally the same formula. Average rate of change. Oops, this is not looking nice. F of B minus F of A. It's literally the same formula. Okay, it is average rate of change, just like the antiderivative of it in a way. So like mean value theorem, it's literally the same thing. So like this whole thing equals average rate of change once you solve it, right? So like it's the same formula. Like when you get to the problems on like FRQs and stuff, you want to use this formula if they give you like a psychoequation for velocity. You want to use the average rate of change formula if they give you like, if they wanted average velocity but gave you position. Do you know what I'm saying? So it just depends on like what you're given, and you use whatever's easier. So average value and average rate of change are essentially the same thing. It's just like whatever you're given to get it is what is hard. If you're doing not bounded, okay, they just are saying like if you take the antiderivative of lowercase f and be capital F. So it's just antiderivative plus c. Here's your table. You guys seen this before. So just whoosh in the brain. Okay. Ready, go. Just put that in there. Okay. Don't forget plus c or you die. You all know that. Okay. Comparison property of integrals. I haven't seen this a ton. I've seen it on multiple choice here and there. We might get it. It's essentially like it looks more complicated than it is. So it's basically like if I were to find the area, this comparison property, if I were to find the area of some rando integral, come on. Now my pen won't work. Hold on. Gotta turn it back on. If I were to do some random integral, wait for it. There it is. Okay, so if I were to find the area under it, okay, so this is like the one I want, okay. What this is saying, this thing, is if I took, like, what's the smallest rectangle I could make over that whole interval? So I know the area under this curve is for sure going to be more than or equal to the absolute smallest height if I were to make a rectangle. So this would be my absolute smallest height, right? If I did a big Riemann sum, that means I know for sure that the area under that curve is going to be more than this area. Okay. So to compare it, if I wanted just like a ballpark value, if I figured out the absolute minimum on this curve on an interval, okay, I know if I'd made one giant rectangle, the area under this curvy guy is for sure bigger than this. And on the other side of it, that's this thing, this capital M business. If I took the highest point on the curve, okay, and found the area under that giant rectangle using that whole interval, I know the area under this curvy guy is for sure going to be less than that. So it's like you use the comparison property for major ballpark areas. So like say you needed to, like given data points, for example, this is useful to know that it's never going to get above a certain amount or below a certain amount. It's like a really general ballpark value is where you do that comparison. All right, so this is here. Maybe I'll write this was the smallest rectangle you can make. Smallest rectangle and largest rectangle basically is what you can make. Just rectangle on the interval. So that B minus A is the interval part, and then the N is like the height for both of them. So gives you ballpark values. So, all right. So we're just going to do like kind of all over the place. I tried to find like the hardest ones. So you're given D prime is the rate that the depth of water in feet changes per hour. If it takes 8 hours to fill the pool, what is the depth of the water? I don't know how much you guys have to like go over this again, but if you have D prime of T, what you would do is you would integrate to figure out you want the full on depth. So we're given a rate, so we're going to have to integrate that. The time is the 8 hours, so 0 to 8 would be the 8 hours, and we're going to integrate your D prime of T. Don't forget dt. And then don't forget to, actually, I'm going to put that in time red, that don't forget the dt, and then now what you're going to do is just find straight up area under the curve. So it's like geometry style. So you basically find area under this. So you just like do a triangle and some count the boxes maybe. But you would find the area, you get 9.5, and then the answer would be in feet. Because we integrated. We did feet per hour times hours. That's why it's feet. So if you're ever not sure with units, think about back to geometry world. If you were to, oops, what am I doing? I'm doing the difference. If I did feet per hour times hour, I get feet unit. So you can always kind of check to make sure you do it. The other type of question is this guy where they give you like some random junk and you have to like figure stuff out somehow. Okay, so for number 3, what I do for these is I usually separate out the most complicated one. So like the 5f minus 3 thing. What I'm going to do is use these rules. So I'm going to break this up. So I'm going to break 5 in front, negative 4 to 1 of f of x dx minus, and then I'm going to integrate negative 4 to 1 of 3 dx and equal 30. So take the most complicated one and just try to break it up. And then what you're going to do is try to figure out as much stuff as you can. Okay, so like for like this thing, this is just random f. They didn't give me anything for that. So that's fun. So what I'm going to do is kind of deal with this guy because that one I can actually find. So for that one, I usually do area for something like that. You don't have to, but I'm going to stall on this first one. Negative 4, 1, f of x dx minus. And then there's 2 ways you could do this one. You could do the antiderivative 3x and plug in negative 4 to 1 to equal 30. But for the constant ones, I usually just do area. I think it's easier in the brain because like this is just a horizontal line at 3. So like here, maybe I'll write, where do I want to write this? I'll write it over here. Negative 4 to 1, 3 dx. Usually, again, I'm more of a visual learner, so this is like my jam. But like what I think about is like I'm going from negative 4 to 1 and the height is 3. Do you know what I'm saying? So I usually just do like an area of a rectangle. Like I'll go 5 times 3 and write 15. I think it's faster for me in my brain. Or you could plug in 3 times 1 minus 3 times negative 4 and then take the difference of it. But it's up to you. It doesn't matter what you want to do. Okay. Does that make sense, like the difference between them? Because now what we're going to do is 1 f of x dx minus, and then I got 15 for the answer of that, equals 30. And then anything I solve, I'll like add the 15 over, right, to get the values of that. So like if I add 15, divide by 5, I can solve for this integral. So if I add 15, divide by 5, what is that, 9, right? Yeah. Okay, and hopefully that's what I need. Just kidding. Okay, so they don't even want that. So then you kind of have to figure out what's going on here. So I want 1 to 8. Okay, so first of all, I'm probably going to have to use the 14. This 14 thing, that's annoying because you see how it's 8 to negative 4? No. Like, why? Why are we doing that, right? Let's change it so it's like normal. Negative 4 to 8 f of x dx, right? But if I switch the bounds, remember I have to change the sign on the value. So I just rewrote it as negative 14, okay? And then now I should theoretically be able to do something with this. So I need 1 to 8, which is kind of like an in-betweener with this. So what I do for these, again, I'm more of a visual person here, but like we've got the negative 4 to 1. I like to draw like a little, like a geometry style segment. So I know negative 4 to 1 is 9. And I know negative 4 to 8. So this whole thing, so this is kind of weird, is negative 14. So this is 9 from that integral, you know, that we did. And then this one is what they gave us, was negative 14. So then I know the negatives kind of like trip me up a little bit, but think about if you did this in geometry, you would take the bigger one minus the smaller one, and that's exactly how you get that integral. So to get that integral, you're going to go 1 to 8 of f of x dx. You're going to take negative 14 minus 9 to figure it out. Okay, so negative 23 would be the answer. Is there any questions with that? So these ones, I don't really have there's not like a clear answer in sight. I just start doing it and then hopefully it'll work out. So that's why I always start with the most complicated one and try to figure out as much stuff as I can and then reevaluate it. Good. Okay. These are just like your OGs, your OG integral. So like number 3. This one, when you're solving it, this is where you're going to do like power rule. So for this one, when you're doing power rule, you're going to increase the power and divide by the new one. Okay. So I'll show you the first step just so you remember life, but like you would increase the power on x to a 3 and then multiply by a third or divide by 3. Okay. Then this one, you would increase the power by 2. We'll do a different color on this. So you increase, divide. This one, you would increase the power by 2 and divide by 2. And then minus 3, increase the power by 1, which is kind of weird because it'd just be x then. And then divide by 1, which you don't really do. And then for the interval, you do this bar and you go from 3 to 5, and then you plug in 5 minus plug in 3. And this is just very painful because of the fractions. So I would probably clean this up before you start going after it. And then you're going to plug in 3, plug in 5. So the upper bound, you're going to plug 5 in. So you're going to go 3 times 5 plus 1 cubed, 1/2, 5 squared minus 3 times 5. So you plug in the upper bound minus, and then you plug in the lower bound. So you go 3 times 3 cubed plus 1/2, 3 squared minus 3 times 3. Be careful that this is all in a bracket so you don't mess up a sign here. Huh? Oh, yep. I know how to multiply. Don't worry, everyone. Yeah, there we go. Yes, thank you. But don't worry, I already did this in my head. And you know what it was? Did anyone get it already? I got 100. Gah! Close. It's so satisfying, isn't it? It's kind of satisfying, you have to admit. Okay, actually, I want you to think about number 4 on how to solve it. Ready, go. Ready, go. Because I need this to be a core memory. Because this happened on the exam, and I don't know if everyone got it. It's trig substitution if you're feeling real ambitious. That takes like a page. You did it like the last day of last year. It's way easy. Graph it. What does the graph look like? Circle. It's a circle. Isn't that sass? It's a circle. It happened on the AP exam, and I was like, gosh, I hope they got it. Gah. No, it's not working. Yep. Okay, so negative 4 to 0. Okay. Now it's just the upper part of the circle because this is the positive root. So if you were to throw this in your calculator, it would only graph a semicircle. If you graph this, to get the full circle, you would have to graph the negative, the opposite. Okay, so we're just doing a quarter circle. So you're going to get 1/4 pi r squared, radius 4. Okay, so 4 pi. Did I multiply right this time? There we go. Thanks. Say you were like, it's not a circle, I don't believe you. Well, just mess around with it a little. You can square both sides and then move the x over. And then you're like, oh, standard form. Okay. Okay, if you're going to do a piecewise, you just break up the areas. Okay, so for this one, notice the interval is messing you up. It's on the 1 is in between. So what you're going to do is you're going to deal with this guy. So from -1 to 1, you're going to integrate this guy. Plus, you're going to integrate this guy afterward. So from 1 to 3. Okay. So then, what's that first one? Oh, yeah. You put it in your brain, remember? Remember when I did that? It went in your head. You didn't see it. There she is. There she is. Right there. Okay. Just put in the head. Go. Okay. Yeah, it's in like an obscure one. It's always like the last question on the test. So, bless you. So it's 2 to the x, natural log 2 from -1 to 1. I honestly, don't you think the area one's easier to do it this way? No? 2 times 4, right? 8, maybe. I don't know. Like, do the area vibe. It's so much faster. And it hurts your brain less. Do you know what I mean? Just do a little rectangle. Okay, so this is 8. And then you just plug in the 1s and all that jazz. So, I put that one on just because everyone forgets it. 2 to the 1, so just be what? 2 over natural log 2 minus 1 over 2 natural log 2 plus 8. 2 to the -1. I threw it in the bottom. Yeah. Okay, I don't think we'll be able to do all of these. Average value. I mean, these aren't that bad. Do you remember the antiderivative of this? So you need the average value of the function. It's not asking average rate of change. That's the key. You have to figure out the difference. So average value means you're going to put that equation into the integral formula. So what you're going to do is you're going to integrate from 0 to pi over 4 secant x tangent x, tangent x dx, and it's 1 over pi over 4 minus 0. So that's the formula for average value. People forget secant tangent, maybe. Do you know the antideriv? Secant. Close, kind of, but not. Okay, so you're going to go secant x from 0 to pi over 4, and then you do your little trig action. Okay, so hopefully if you do 1 divided by pi over 4, just write it as 4 over pi for your sanity. And then you're going to plug in those values. Ready, go. Secant. Got to remember. How do you do secant? Just do cosine, flip it.
Oh, never mind.
Okay. Okay, did we get it? Root 2 minus 1. Hypotenuse over adjacent. That's the easiest way. Yeah. Okay. Then okay, mean value theorem for integrals. Basically, you find the average value first and set it equal to the function. That's what you do. So you find average value. So you're going to go 1 over -3 minus -6. Integrate from -3 to -6 of the function -x squared minus 8x minus 17 dx. So you figure that out first, and you get a number. Okay, so you find the average value, just like how you do the average rate of change for mean value theorem first. You're going to do the same thing, but now it's just average value. So you're not doing like slope, right? Because they're asking for average value versus average rate of change. So once you find the average value, did it all in my head. It was -2. Okay. -2. So blah, 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 math, 2, -2. Okay. Second thing, you're going to set the -2. So you're going to set -2 equal to your function, but they want a value c. So instead of x, you put c in it. So you're going to put -c squared minus 8c minus 17. And then you do math. And then you're done. Okay. So this is a little quadratic-y. Okay. Why are all those negatives there? No, thank you. Let's change that to positives because I can. Okay, then I'm going to scooch over the 2 and do a little factoring. Please be factorable, otherwise I'll cry. Is it? 5 and 3. Thank goodness. -5, -3. Those are the answers. So, okay. So, average value with mean value theorem, you find the average value, just like how you find the average rate of change first for mean value theorem. And you do this. Now, they gave you a polynomial, though, so you can get by without saying the differentiable on the interval. But, like, technically, you should say it if it wasn't, like, a nice function. So, because f of x is differentiable, therefore continuous, is differentiable, therefore continuous. Yeah, pretty much. It's just, it's like the antiderivative of it. Yeah. Are they going to make you choose like which one to do, or could you? No, they'll say average value. They'll say like use the mean value theorem to prove there's an average value. Yeah, they'll say it like that. Is that one of those questions? Yeah. This is more multiple choice, this one. FRQ would be like giving you a chart. For rate of change. It says mean value theorem for integrals. That's why. Yeah. 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 Okay, we'll do this last one. This one is show that it lies between. Nah, we'll be done, actually. Oh, do you know the antiderivative of 10? Almost. Yeah. Don't forget plus C. There we go. We did one of those. So. Okay, that's it. I want to give you your test back.